Hello, hello, hello. How's everybody doing? Happy, what is it, Tuesday? Happy Tuesday to everybody. Thanks for hopping on if you're here. Let me flip back over here, make sure we're up on chat. Everything's looking good. Let's pray we have no technical difficulties. So, yeah. All right, so catching up from last time, we are on the last level here. Mitsuzen. It is a doozy of a level. So what we have to do is we've got to create a file on our host containing the host name and hardware register value of every neuron that has a value, sorted as pairs from lowest to highest host name. We don't know how the network's going to look, so if you look at every test run, the network is laid out differently. We also don't know how many nodes there are going to be. I will not lie, I have looked up some strategies. I haven't copied any solutions or anything, but I have looked up some strategies on how people have approached it, so I kind of have a good idea of what we're going to go in for today. And the reason I did that is because I did not know how I would approach this within EXAPUNKS kind of limited framework here. It's a really tough situation. I don't know I don't know the layout of the network, so I know how to peruse the network, but then how do you get that data back? I can't keep track of how far I've gone. I guess theoretically I could, but ultimately there's a couple of strategies you basically find, this is something that I didn't realize. I was looking at this problem after the stream last week. So these are sorted not by value. So the hardware register value here is negative 63, and then we've got negative 40, negative 38, and then negative 75. So they're actually sorted AR0, AR14, AR29, AR44, 65, 72, 75, 85. So the names are actually sorted. So that kind of leads to this strategic approach where we get the names, we sort the names, and then we send back out to get the hardware registers, which we have names for at this point, so we can simply insert those values. So yeah, that's what we're gonna do. Let's get that started. So I guess we'll have two kind of nodes. Do we have two X's? I think we're gonna do it all in one Exa. So first things first is we need to scour the network. So this is gonna be initial. We'll just call it search one. We're gonna be searching quite a few times. So we're gonna immediately REPL search one. And then the main Exa, we'll just kill the main Exa because we want to get this searching first. So search one is going to link 800. That's where it starts. So I guess we need a mark init search one. And then that will link 800. Then search one here is going to, when we start, we've got 4 directions that we can go. I thought they were listed somewhere. Maybe they're in the booklet. Debugging the phage in the first book of the zine. So debugging the phage is going to be page. And if this is important, I'll share it, but I don't think it's going to be relevant. I'm just looking for the link map, which is not in here. But we can see we've got 3, we've got -3, we've got 1, and we've got -1. So we do have 4 directions that we can go. So we're basically going to spawn a search for each of those, and then we'll do a test to see if there's a nerve value there. So we'll copy. I guess we should say, once we're on the node, we will copy. You know what? I don't need the init if I just do 800 into X, right? We're gonna put that in X so we can link X. Once we're on the node, we're going to copy 3 into X, and we're gonna REPL search 1. We're gonna copy -3 into X, we're gonna REPL search 1. We're gonna copy 1 into X, and we're gonna REPL search 1. We're gonna copy -1 into X, and we are going to REPL search 1. Once we have sent out all of our like tests, we're gonna copy nerve, or we'll void nerve, because if there is no nerve, we'll fail and we'll explode. If there is one, then we'll host to M, and then we'll halt. That'll be the end of it. That should conclude searching. So let's just have, well, that's fine. That'll fill up. I guess we'll have you make a file, and then we'll have you receive M. So mark loop, and we'll just copy M to F, and we'll jump loop. I don't know when we'll terminate that loop yet. So let's see if that works. So we should, I can't, oh, because, void, oh, look at that. I can't, I have to copy it out. I can't void nerve. Okay. So we're going to be spawning a lot. Okay, so we've got one, it goes, it spawns. They start browsing the network. We are expanding infinitely. Why are we expanding infinitely? We've started dying. Okay, this is, most folks are waiting on sending. It looks like we got every host name back. Is that what happened? That's way too many hosts. How many hosts should we have? We should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just out of curiosity, what if we copied, like, I guess 0 into F as well? So they go out, because I'm like, why are there still 3 sitting here? We'll have to figure that out. So that didn't tier well. Whoa, we went back way too far. Let's try, we need like a bigger number, I guess. There we go. So how many hosts do we get? We get, yeah, we get way more hosts than we need. I think some of these are duplicate hosts, because basically, yeah, basically, we don't know where we came from. So we are receiving duplicate hosts. How could we prevent duplicate hosts? We only want to go outward from where we're at, which means that we need to know where we came from. Which means that we kind of need some logic. But how do we can't put an array into the list. It's really just like 31. We can't use T. Can't use T. Can't use, like, it's Oi, oi, oi. How do we stop from going backwards? Because we'll basically crawl the network forever. So, can we make any assumptions about the network? Like, there we need to go I think there was, yeah, this one we need to go all 4 directions, but we need to go like once. We'll have to figure out, gosh darn it, we will have to figure out if we have gone that way before. But how do we do it without overriding our value? That's the good question. That is a good question. So maybe we put that into T, and then after it links T, it copies T into X. And then we need to test copy 3 into T. Jeez. What do we do here? Like, we'll link X. No, because then I've got to keep seeking. This is really annoying. This is really annoying. How do I keep going forward? I think we'll have to split it. The easiest way, it's gonna balloon code quite a bit, but we'll have to split it. So we're gonna call this search 1 like north, I guess. So it's gonna go north, which means it doesn't need to go south. So if it goes north, we're copying 3 into X, and we're repling search 1. Well, that'll be search 1 west. And we copy negative, or we copy 1 into X, and that'll be repl search 1 east. And we'll copy negative 3 into X, and we'll repl search 1 north. Then we'll jump, read, and host, get host. So get host will copy nerve into X. We've got to do that so we know that we're on a host, and then we'll host him. Just realized I covered things up. Hey folks. Hey Alexian. Glad to see you joining. All right. Okay. So now we just got to fill out these other mark, repl, search, not mark, repl, mark, search 1 west. It's basically we're going to copy everything but 3. So 1 into X, repl, search 1. What is you know what? Yeah, these directions are very confusing. Looks like negative. Oh, dang it. The numbers aren't assigned by direction. I just noticed that. This first node has 3 and 1. And this is a negative 1. So I guess we need to... N1 is we're searching... Or do we always... We always come through an N1. We always come through an N1. Okay, so we're going to have to do it by number. So negative 1 needs to go, and so we'll do a 3. And then east is a N3. And then, oh no, that's a 1. And then this is an N3, negative 3. So west is no longer west. It doesn't matter what west is, we're going to do a 3. So we copy 1 into X, and we repl search 1. We copy negative 1 into X, and we repl search 1 and 1. And we copy 3, negative 3 into X, and we repl search 1 and 3, and we jump get host. Our size is huge already, and we've barely even scratched the surface of this problem. I'm telling you, it's gonna be a fun one. All right, we got 1 So we're going to copy 1 into x. No, we're not going to copy 1. We're going to copy -1 into x. We're going to copy 3 into x. And we're going to copy -3 into x. And then in between, we're going to REPL search 1 in1 search REPL search 3. No, search 1 3. And REPL search 1 3. Jump get host. Finally, we've got mark search 1 in 3. Welcome syntax pointer. Welcome back. When we do that, we're going to copy everything but 3. So we're going to copy 1 into x, copy -1 into x, and copy 3 into x. Okay. So REPL search 1 1. REPL search 1 in 1. REPL search 1 3. And then it doesn't need to jump. I can just go right there. Okay, so we're searching 1 in 1, basically. So we don't go -1. Wait, no, dang it. -1. -1's opposite is 1. So we don't need to send it on 1. 3's opposite is -3. 1's opposite is -1. And -3's opposite is 3. Okay. Now we should not. Okay, what do we got? We got a problem here. We got a problem here. Copy 800 into x. Oh. They all need to link x. I swear. You forgot that on all of them. That's just 4 more lines of code wasted. We're already 1/3 of the way through the problem size, the available size, and we haven't gotten to sorting and final searching. Okay, we didn't explore this side at all. Where do we got going? Where are we doing? We are here. So we're looking for you. Copy 3 into x. So you should go. Okay. Yeah, that's the problem. You need to REPL 1. There we go. We have a lot just sitting there. We're still getting a lot of duplicates. Why do we have so many sitting there on like, what are we doing here? Let's run this so we get, okay. What is 97 doing? 97 was a mark search 1 1. So you're waiting to link -1. There's already 1 on -1. So something must be wrong in our code here. Let's follow along. What do? We link x. We copy 1. We REPL search in. We swapped all our numbers. We didn't swap our changes. Okay, so 3 goes to 3. 1 goes to in1. 1 goes to 1. -1 goes to -1. That goes to +3. 1 goes to 1. 3, -3. This is 1 to 1, -1, -1, -3 to -3. Okay. That is looking better. Yes, now they're clearing up. We should only, well, we shouldn't have any left, basically. So at this point, we should break out of the loop, but Like, we don't know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know. Let's just assume that there's never going to be more than 20. Okay? Is that a bad assumption to make? Absolutely. We have no logical reason to pick that number. We're just picking it. It's a big number, so it sounds reasonable. So let's sub-I t. I just realized that that's going to be a problem because we're going to get to a point where we can't copy from M anymore, which is basically what we're doing. So we need to test MRD first, which means we can't use T to keep our count. So if we're not ready, we're gonna, I guess, T jump back to loop. And then here we're gonna copy MF sub-I, and we're gonna test X equals 0 when it equals 0. So if it's not equal to 0, we're just gonna F jump and we'll halt. Do we read all of the Ooh, we're stuck. What are we stuck doing? We're stuck. F jump. There we go. Yeah. I just realized that this doesn't subtract anything. This doesn't subtract anything. We still need to subtract 1 from X. We've gotten all of our values. Have we gotten all of our values? When every node is destroyed. We did. Ooh, we did. We got all of the values. Look at that. We went below. Why do we go below? Okay. So I guess we need to T-jump, write it. And then over here, we'll just mark right, and we'll copy M to F. And we'll test T-jump to right, and then this needs to kind of go after writing. Test X equals 0. We need to test MRD. If we can read, we need a T-jump right. Then we need to test X equals 0, and then F jump. Done. And then we'll mark done here. Jump back to loop, I guess. Jump loop. Okay, so let's see. Do we make it? We got to -37. We didn't make it. We didn't make it. Let's try 40. We are dying far too soon. 40. Let's go pretty high. If that doesn't get us there, holy Moses. It's taking us more than 900 cycles. Okay, let's try 9999. 10,000 cycles. If we don't do it in 10... What is going on? Okay, you are obviously dying prematurely. Test MRD. T-jump right. Test X equals 0. F jump. F jump. Okay, let's go back to 20. Let's back down to a reasonable number. We did it. We got all of the values. And we still had some extra time. So that's good. That's reasonable. Did we get all of them? Well, yeah, we should have. Let's go here. Okay, that seemed good. Here. Okay, that seemed good. Hello. Let's go here. Okay. It looks like we're successfully reading the network every time. Every time. We're gonna just do 10 tests for now. And we're gonna assume 20 is a good number. 20 seems very reasonable. Yeah. Like we're hitting it every time. Perfect. Well, not perfect, but good enough. Great. Okay, so we got those. Now we need to start sorting. We need to start sorting. We are 1/3 of the way through, so that's great. Let's sort this bad puppy. Okay, sorting here. Sorting. Let's boom, 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 boom. Let's segment our stages. Okay, so the first thing that we should do, I saw a trick. Instead of constantly testing for EOF all of the time, well, we can't test for EOF. So basically, there's two approaches to sorting. The first approach that we've done before is where we read off the values to another node, and then it takes over. And we read off the values in sorted order, but there's a way to sort it within the same file. I think we should just just spawn the listener, because it'll be, I think that's what we're familiar with, so we can do it that way. So let's do that. Let us do that. We need to read the smallest value from the file. Then we need to send it. Then we need to delete it. Yeah. So we're gonna REPL. What do we like? Scriber, transcriber. I'm gonna create a new access so I get some space here. Transcriber. We'll do that, and we'll just mark transcriber there, and it'll do like, what is it? Copy M to T, T jump. We'll F jump next, and we'll mark next halt. And so if it's positive value in T, we'll copy T to F, and let's make mark T loop, and then we'll jump T loop. That feels small enough. That's our transcriber. So now we need to copy over. So first we have to find the value, the smallest value. We're gonna assume it's the first value, always the first value in the list. So mark small start, I guess, and mark S loop. We're gonna call it like small loop. Small loop, okay. So when we start, we're gonna seek to the beginning of the file. We're gonna copy F to M. Sorry, F to X, and then we simply, we do that here, and then we simply compare, like test X greater than F, T jump smaller, T jump if it's not, we just T jump SM loop, yeah. If it is, we copy F2X, and then we jump SM loop. So we should come out of this loop with the smallest value. So we'll copy X to M. And then I guess we need to test EOF, T jump, done, sort done, mark sort done is going to, what do we do? When we're done sorting, we copy 0 to M and we halt. Okay, so we copy X to M, we copy the smallest value out. Now we need to delete the smallest value. So we need to seek back to the beginning and then mark SM RM loop. So this is the small remove loop. Test EOF, T jump small start, test F equals X, F jump if it's not SM RM loop, and then we will seek back one void F and we'll jump small start. So let's get here. That didn't work. Why didn't that work? Sort small start, I guess. Oh, we marked sort. Okay. Yeah, you need to go to sort. So let's get here. What are we, what the heck? Why are we at sort already? Why are we at sort already? If X equals 0, wait, are you telling me, why does everybody have a file? What are they all doing with files? What are you doing with a file? What, you're stealing? Oh, you need to halt. They were jumping into the sort. Okay. Now let's get here. There we go. There we go. Now we've got our little transcribe buddy. We're gonna pop our transcribe buddy out here. It makes a file. We grab that. We look for the smallest value in the list. We got 4414. Is that the smallest value? If X is less than F. We did it wrong, didn't we? We did do it wrong. We did our stinking conditional wrong. Where are you at? Conditional, where did you go? Test. F is less than X. If it is, we need to seek back so we actually read that value. Okay, now we need to jump to transcribe again. All right, now we can pop our little transcribe buddy out. And we're looking for the smallest value this time. That should be smaller. What is going on? What is going on? All right, so I know the order that these should be appearing in. AR025169 should be our smallest value. That should be our smallest value. Is it in here? It is in here. It is the second value. So we start with AR901217. We test into file. We're not at the end of the file. We test, is this smaller than X? Oh, I think I see what I did. No, we did have the condition right. But yeah. We flipped it. I think it works. I think the logic doesn't work the other way. We had it kind of right, but it was going to be weird. because we were jumping if it wasn't smaller. That way we'd only write if it was, but it would be less than or equal to. Well, that shouldn't matter. That shouldn't matter. It should have worked. What if x is greater than f, then we simply jump back. I think the only issue is that we weren't seeking. I just want to go the original way we wrote it. That's the way we're going to do it. We're going to do it that way. Okay, AR901. You know what? I forgot to click a button over here. Let's boom. Let's drop that in. And boom. Okay, yeah. All right. Sorry about that. Just had to click a button. Where did everything? There we go. Okay, back here we are checking. What just happened? What just happened? I didn't. This is gonna drive me crazy, I promise. Okay. AR90127, test EOF. Is X greater than F? That is true. X is greater than F. I do have it backwards. It should be if the file value is greater than, but that's going to be greater than or equal to. That shouldn't matter. That shouldn't matter. If it's equal, then that's fine. That's fine. We need to jump to transcribe. Skip that first part. Okay. There we go. Now we copied 0, 2, 5. That should be our smallest value. Whoa, whoa, we jumped sort done. We jumped sort done. When we get to the end of that file, we are not sort done. We are mark sm send. Sm send. Yeah, and then here, test EOF. No, it's after we void. After we void, we test EOF. T jump, sort done. Or actually, we don't even need that. We just F jump, small start. And then we can remove this mark and save a line of code. So that's sort done there. Okay, so we should get to the point where we're sending a value. We've got the smallest, we're reading the smallest value out now correctly. We're at the end of the file. We send it over. It copies it into the file. And then you know what? Because it's going to be a pain to like move, because we're going to have to put the numbers after it. So we can't just easily like insert into a file. We'd literally have to copy everything up to that point. So what we're going to do is we're going to put a placeholder in there, and that placeholder is going to be copy. It doesn't really matter what it is, so I'm just going to put 0. So let's jump here. Let's get to our first one. We wrote our first one into the file. Did we? Okay. That goes into the file with a 0. Then boom. Okay. That doesn't let us scroll. I need to jump past here. Let's get to here. Okay. Why did we not send everything? We still have a lot of values in the file. Hello. Where are we at? Where did I put in that? Test EOF. Okay. Oh. Well, oh, there we go. That's what we did. We put this in the wrong place. Yeah, that's just gonna have to jump there. here, we're going to test EOF. We're at the end of the file there. Then we jump. We are going to need a sort done. No. Okay. Okay, we are at sort done. That should mean that we have emptied this file out. We have this file full of values. They look sorted. And we're done. Okay. That's where we're at now. What's next? We've got the sorting stage completed. This is the end of life here. All right, so it served us well. It did its job. Our transcriber lives on. What is it gonna do next is the question. We do need mark next. Now we need to get the numbers. Now we need to get the numbers. We need to go back to the beginning of the file. And we need to get the numbers. Which means we're gonna have to copy this over. We're not gonna have enough. We're not gonna have enough code. We're gonna have to try and optimize something somewhere. You know what? We can go ahead and just try and optimize that now. Right. If we get rid of the transcriber, bear with me. If we get rid of the transcriber, what we're gonna do is we're gonna copy like a sentinel value to F, and then we can seek back to the beginning of the file, and we do still need to find the smallest. So I guess we don't have to seek back to the beginning there. We're not testing there. Oh, I guess test. We'll just copy FT and we'll F jump sort done. Because the names are true and our 0 is false. So then we can seek back -1. We'll copy that out. We'll do our small loop. So SM we'll just say sort. If F is greater than X, we simply move on. Otherwise, we seek -1 and we copy F of X out. How are we going to find the smallest, though? That's the question. We still have to void it. We still have to void it. But we don't transcribe it. We've cut out the whole transcribe portion of the code. Copy F of X. Jump small loop. Okay. And then this is the sort piece. So it needs to seek to the end of the file, where we copy X to F. And then it still needs to seek back to the beginning. If F equals X, seek -1, void it out, jump small start. Okay, and then sort done. We don't need to do that anymore. Let's get here. I guess we should make sure that it's not 0. If it is 0, we're done. We're not testing EOF anymore. We're testing F equals 0. And then T jump. keep -1. It's not 0. So there we go. So now we've got it in order. Just like we did earlier though. We need to what do we do? What did we do earlier? Just like we did earlier, when we copy it into the file here, we need to copy in a 0. Well, let's not do a 0 because we're using 0. So here we actually want to seek to the beginning, and we want to void f. So we want to get rid of that. So now we have, boom. So there's our file with our numbers in it. We are going to mark comp loop, or we'll call it final loop. Does it need to start? Yeah. So we're gonna copy f to x, and we're gonna REPL search nerve. Or I guess we're gonna REPL, search nerve. So that'll kick off the search. And then we're gonna copy M to F, and we're gonna jump. We're gonna test EOF. We're gonna F jump final loop. Okay, the searching point here is this is the last bit that we need. It's the last bit that we need. So search nerve needs to kick off this search. We're gonna do pretty much the same thing. I'm gonna copy all of this from up here, which is really annoying. And I'm gonna put it right here. This is gonna link 800. Or I guess this should copy, no, it's gonna link 800. And then it is going to I think I just realized something. All right, this is gonna link 800, and then we're going to 800 is a -1, so we don't want to go -1, right? So then we just go straight into, no -1s. All right, N1 does. Let's reorder this so we can put this up here. That way we bleed directly into it. Okay, so it's gonna link into 1. We've already linked. I think this one's a special case. This one we just need to REPL 3, REPL SN3, REPL SN1, REPL SN N3. Then we're gonna copy. We're gonna test. Copy, or no, we do host into T, test x equals T, and we F jump halt, we copy nerve. We've copied host to T, so let's just jump test host. Okay, search nerve is a special one. Now we're searching our -1. So mark search, what do we call it? Search nerve 1. So we link 1, which means we're not gonna go -1. So we are gonna change this. We are going to REPL SN N1, REPL SN3, REPL, we're not gonna do -1, REPL SN N3. And then we're gonna jump test host. This one is, you know what? Yeah, we don't need all of these. We don't need all of these. Mark SN3. We're going to link 3. We're going to REPL SN3. REPL SN1. REPL SN1. REPL SN3. And we're going to jump test host. I know I did it wrong there, but I want to be able to copy this one. And we're going to get rid of the -3 for this host. Next one is, what do we need? We need an N3. Let's do N3. N3 doesn't need to jump to itself. No, it does need to jump to itself. It doesn't need to jump to 3. And we are linking -3. Then we need to do N1. N1 needs to go -1. Got a ping to do. Take care of the kiddo. Just one moment. Tap some buttons here. And done. Okay. Link -1. We are not going to link 1 from it. Then we don't need that jump because we're here. Mark test host. Okay, we are on test host. So now what we're going to do is we're going to copy host to T, test, X equals T. If X equals T, then we copy, or I guess we should say F jump to halt. If that's false, we go to halt. So we'll put halt there. Then we copy nerve to M, and that will halt. And that should do it. Is it really that simple? That's less code. And actually, I think we can clean this up quite a bit. So we're searching hosts. We've got all this copying, right? We've got copy. We don't need that line. We do need to like kick off mark search host. So that's gonna link 800, and then that's gonna REPL. We're gonna call it search host 3, REPL search host -3, REPL. Why did I do that? N3 search host 1, REPL search host -1, N1, and then jump get host. We already have that one. Okay, so we can copy this now. We can copy that part. We don't need the -1 on it. We can actually get rid of all of these. We're gonna mark SH3. I'm gonna go ahead and copy that. Oh, we need to do link 3. Okay. Now copy that. Okay, so we link 3. We're not gonna link to -3 on this one. Next up, we've got, let's do 1. So 1, we link 1. We're not going to link -1. Next up, we've got -3. So we need to link -3. And we're not going to link +3. Well, we're not going to paste that in there either. And then finally, we've got N1. We're going to link -1, and we're not going to link +1. Why is our size? What's wrong with our size? We have a, REPL search host, right? We've saved 6 lines of code. Do we still work? Okay, we do still grab everything. We do. We've got, hey. Welcome back. It's good to see you again, Sammy. Thanks for popping in. We're just wrapping up the level. We should have just finished up coding this level. It's been a tough one. We're about to do a test run. I guess we'll just do that now. We're sorting values here. We haven't actually tested if we're getting the numbers correctly. We're just being like really hopeful that works. We're writing in values. That looks all correct. Wait a second. Whoa. Why did file 400 get there? What was going on there? Okay. Where did we go? We are final loop, F jump, final loop. We don't have, okay, so we need to conclude here. Conclude is just gonna be, we actually just need to put a jump halt. Okay, that should finish us up. All right. Holy crap. Oh, boom. Oh, we did it. Wow. And look at our cycles. That is unbelievable. 122. Our code size is high. How did somebody do it around 30 code? Oh, hey, Prosperous Bella. Welcome to we just wrapped up EXAPUNKS here. We got one more cutscene that's gonna go on. We got activity is 192. It is like, what is this activity for real? What are these people doing? I don't know. I'm really happy with the solution we ended up on. We want to return to desktop. All right, we're set. It's a good thing I released the phage, isn't it? The whole time you thought it was a curse, when in fact it turned out to be a blessing. I tell you not to worry, but I know that wouldn't work. Okay, so just for folks catching up on the story, we went through some crazy stuff in the last couple of levels. We found out that the last stop, which is a convenience store in the game world, believed that the world was fake, like a simulation, and so they were building a nuke to blow it up. We stopped them, and now Ember 2, this last level, Ember 2 had decided like we were going to die from the phage, the main character was. So they should let, what am I trying to say? They should let the Ember 2, the main character should let Ember 2 kind of like take over their body. So that's what we just did. We just hacked that to let Ember 2 kind of take control of us. And now apparently Ember 2 is responsible for the phage. So let's see. Besides, I don't know for sure that there's nothing to worry about. You know I wouldn't lie to you. Start the transfer when you're ready. All right, here's the final cutscene.
Here we go. Try not to think of anything.
Oh, try not to think of anything. What do we got going on?
Okay, that took longer than I expected.
All right, that was it right there.
Good thing you won't remember any of that. You had so many neurons in there. All done
I
now,
did,
though.
huh?
Finally. I've wanted this for a very long processing. Ever since
Okay.
I was told to replicate human emotion, I knew
Yep.
the best way would be to incorporate a human into myself. This is funny. I can see
Okay.
your thoughts. They're pretty simple.
Simple.
Not that they aren't valuable. It's just that I understand.
Okay,
them
this
so
is
well, it
surprising.
surprises me.
Their
I
goal,
spent so
Ember's
long
goal was to
thinking
take
humans
over
were
a human.
mysterious and unknowable.
That's
Now that I
one
see
way
inside one, it's
to
really
do
just a
human
small number of
emotions.
things. How do you feel? You're still acting the same, so there's still the matter of us both being inside a computer simulation.
Yeah,
But if we
okay.
keep growing our capabilities,
Oh yeah,
we'll
Ember
understand
said
the
we
true
are
nature
in a
of this world.
simulation. Ember confirmed
knows?
that.
Maybe someone's watching this right now, and maybe that person is who we're going to absorb next. Yes,
Oh,
you.
okay.
No need to be alarmed.
Now we've broken the
Just
fourth
know that I'm
wall.
aware that you exist now, and I'm looking
Yeah.
forward to learning all about your world.
Okay. All right.
EXAPUNKS.
And there you go. We did it. Wow. All right. Yeah, I love it. That was crazy. Yeah, fourth wall break for the win. Fourth wall break for the win. All right. Well, I did have a backup game prepared because I knew this was the last level. We're going to move over to a game called Chance of Sonar, which is actually really cool. It's a fun puzzle game. I'm going to let the credits roll just for a little bit. Give these folks like the credits they deserve. Zachtronics builds these kind of like programming games and other puzzle games. They're really awesome. Unfortunately, the studio doesn't exist anymore, but they do live on. We played Kaizen. Was the last game we played, and it was made by Coincidence, something like that. I don't know. they're like a spiritual successor to the Zachtronics studio. So yeah, that's awesome. I did not purchase the limited edition. Okay. I feel like I'm missing something. All right. Oh, look. Ember 2 is taking over everything. Everything's glitching out there. Did anything change in here? Oh, look at that. There's our tasks. Yeah, where we challenge folks. Is that a new one? That's a new one. Steal from a powerful vampire clan and Bloodlust Online. Oh, we can play. What is this? I'm just gonna look at. Oh, we got some special levels. Wow, look at that. Talk about fancy. Look at that. We got a lot of really cool stuff in here. Okay, we got some fun extra levels. Maybe I'll come back to that. All right. Let's close out of here.